Alright, in this video we're going to troubleshoot circuits based on their diagrams. And so one of the things we always want to be on the lookout for are short circuits, which are places where the electricity can get from one end of the battery to the other without going through any resistors. So anyway, here is the first thing. We want a circuit with two bulbs that are both turned on or off by switch X. So switch X is here and is currently open, meaning no electricity can cross it. So one way to troubleshoot a circuit is to start at one end of the battery and imagine the electricity is moving along. So if the switch is open, it's not going to go anywhere. It's going to get stuck at that switch. So if the switch is closed, then it will be able to cross, and then it has a choice to make. So it can either go down this path here, or it can go down this path. Now electricity typically follows the path of least resistance. So both paths reconverge here, and so the choices are go down this wire or go through this bulb. So the path of least resistance is to go down this bulb, and then it has to go through this bulb to get back. So this bulb's going to light up, but bulb A, because this is the much easier path, is essentially going to be bypassed. So this is sort of like a short circuit. It's not a true short circuit in that there is some resistance in the circuit here, but basically bulb A will never light because almost all the electricity is going to flow through here. So this is what is wrong with this particular circuit. If this were to be done correctly, this light bulb here should be moved onto this wire. That way the two different pathways are equivalent. You either go through this bulb or this bulb, and when they reconvene, there's nothing else here. This bulb would be gone. So that's the issue with this particular circuit. In this situation, I want each switch to control each bulb. So again, I'm going to start at one end of the battery and say, alright, I'm traveling along, and if the switch is open, I'm stopped right there. So right away, if this switch is open, then nothing's going to light. And what that means is that even if I close this switch, this bulb's not going to light because the electricity will never even be able to get over to this region. So that's the first problem. There's no independence here. If this switch is closed, switch A, then yes, this one will be on X, and then B will affect Y, but this switch has to be closed for anything to happen. So how do we fix this? Typically what I say when I draw circuits is I try to keep everything off this top line as much as possible. So just make this a solid line, and ideally you'd put the switches on the lines themselves with the bulbs. That way each switch will directly affect its bulb and no more. And so this would be a better way to draw this. Okay, so here's one that uses a single pole double throw switch, which I usually just refer to as a three-way switch because it has 3 points of contact. And the way these work is they either flip up or down. It's like a train switch station. So again, just like any other switch, you imagine what it's like in each position. So if the switch is up, meaning it's connecting this way, what will happen? So the electricity would go through, up, through the bulb, and this would light up. You say, okay, what would happen when it's down? When it's down, the electricity would go up through, and then it would have no reason to go through this bulb. It has a short path to get back to the battery, or a short circuit. And so this is really bad. This is going to overheat the batteries, maybe make them explode. You never want a short circuit, which is a path where there's no resistors on it. So this is a bad design. There's really no need for this wire at all. You just take it out, and realistically you would just use a single regular switch for this situation. There's no real need for this at all. So anyway, those are a few different ways to troubleshoot a circuit diagram. So anyway, until next time, I am Derek Genova. Have a delightful day.